Well, hello everybody. I'm happy to be making this video as a follow-up to my discussion prompt. And I want to just answer it this way. A function value and a limit are not the same thing. And what I mean by that is they might be different and you can't use one to judge the other necessarily. Okay, so let's go through this. Here's the function that I was using in my example. Okay, this is a function. What's a function? Inputs and outputs. You put a number in, you get another number back out, potentially. All right, number in, number out. That's what a function is. This is the function value if x is 3. Okay, so this right here is what happens if you let the input or the x be 3, for example, or I'm just using 3 as a number in my example. You plug 3 into the function, you do some calculations, hopefully you get an answer, but sometimes you don't. This time it's undefined. All right, so we got our function. We got our function value if you let the x be 3. And then something completely different is the limit as x goes to 3. Now look, already I see something different. That's an equal, and this is an arrow. That alone would tell you that a function value, meaning plugging a number into a function, is not the same thing as a limit. X equals 3 can't be the same thing as x arrow 3. I mean, they're different symbols, different notations. Okay, so yeah, all right. This is the limit as x approaches 3 or as x goes to 3. That's how we would read that. The limit as x goes to 3 as applied to the function x to the third power minus 27 over x minus 3. So here's what we're looking for with the limit. All right, hopefully I've established that it's not the same thing as letting x be 3. Okay, so when we want to know what happens when x approaches 3 for this function, we are asking if there's any kind of pattern in the function if the x gets very close, progressively closer and closer to 3, but not equal to 3. Okay, so it's like, I already know that in this function, if you plug 3 in, nothing happens. You don't get an answer. But what if you're near 3? Is there some appreciable pattern for x getting very close to 3? All right, well, okay, how do you think you'd answer that? Turns out there's lots of ways that you can calculate limits, but I guess the way that is most intuitive to what I'm describing here is to make a table. Now, it's not the only way, but it fits with our discussion right now, okay? So I was going to figure out, in this function, is there any kind of pattern if the x gets very close to 3, progressively close to 3, that arrow is suggesting that that's what's happening anyway. Okay, but not equal to 3. 3's off limits, but I want to see what happens when we get closer and closer. So I make this table to illustrate that. Do you think this table right here, these calculations, would roughly illustrate that idea of I want to know what happens as the x gets closer and closer and closer to 3, but not equal to 3. So in my table, I say, we're going to find patterns. I have lots of numbers, okay? I don't want to just use one number because I want to see if there's a pattern, if there's a trend between the x and the y. So I did 2.9, already close to 3, 2.99, even closer, 2.999. And I can put more 9s if I want to. And then on the other side, because I want to go close to 3 from both sides, 3.1, already close to 3, 3.01, 3.001. And I could put more zeros in there if I wanted to. Now, but is this enough to convince us that there's a pattern? Well, okay, so 2.9 gives me 26.11, 2.99 gives me 26.9, 2.999 gives me 26.991. So if you look at this, it looks like the closer the x gets to 3, that's the cause, I guess you could say, right? I mean, a function has inputs and outputs and cause and effect and so on. So the x is the cause and over here is the effect, right? So it does look like the closer I push the x to 3, the closer that the y gets pushed to 27. Do these numbers look random? They don't look random. Okay, there is a pattern. It looks like there's a trend. It looks like if I put another 9 over here, 2.9999, I would get some number that was even closer to 27. Okay, all right. So that's the pattern that I see. I hope that you see it too. And so there we have it. Our limit was going to have an answer of 27. Okay, all right. So, okay, let's go through this. There's the function. If you plug 3 into the function, you don't get an answer. It's undefined. But if you let the x become progressively closer to 3 in that function, there's a definite pattern that the y gets closer to 27. All right, that's what we're looking for the limit. That's what makes the limit different than just the function value. Okay. All right. Now, as a disclaimer, well, let's say this. I want to follow up. There's always some fine print in math. Math's complicated. So a function value and a limit are two different things. Hopefully I've established that with the example up there. They can be the same thing though, but it's just coincidence. Like, so for example, here's a much simpler function, f of x equals x squared. And if you plug 3 into that function, you get 9. Okay, that's the function value. But look at the limit. What's the limit of the function as x approaches 3, as x goes to 3? Well, say I make a table again, and I do 2.9, 2.99, 2.999, and so on, 3.1, 3.01. Say I make a table, and I tell you, well, all right, right here, this is what x approaches 3 roughly means. What do you see over here? What happens to the y? Are these numbers random without any pattern at all? Well, it looks like the closer the x gets to 3, the closer the y gets to 9. Yeah, so okay, the function value and the limit, they might match. Yeah, but not necessarily. All right, that's my point. I don't want you to think that just because when I plug 3 into this function, it means that that's the answer to the limit also, because it's not. All right, it might be, but that would just be coincidence. Okay, so that's what I wanted to establish in this first discussion board prompt. Okay, now I have to have a disclaimer because there's lots more to say about this. There are many other ways to calculate limits besides tables that we'll talk about as the semester goes on and that are addressed in videos I've already posted. And limits do relate to other concepts such as continuity, and so those things I'm not addressing in this video or in this prompt. But for now, I just want to make the point and have you understand that x equals 3 is not the same as x arrow 3. They're two different concepts. The thinking around them is different. Everything about them is different, right? And so I don't want you to think they're the same thing. Okay, so that's why I posed the question in my initial prompt as, could they be the same thing? I wanted to see what you think. But hopefully now we've clarified that and you feel like you understand it.